Hey everyone, how's it going? We are going to be finishing I believe today, we will be finishing the intro basic tutorials for all of Pytorch. There's a lot more tutorials to go. The good news is we built our model successfully yesterday. We trained it, it learned. Now we're going to test it on our test data set. That's the plan for today. We're going to go to the bottom half of this tutorial to make sure it looks good. Then we will be jumping into the save and load model, which will conclude this week of all the basics, the beginner basics. Although it feels like it's been pretty advanced so far. The good news is we have a lot more to go. There's nowhere near done. Hey, it's Neva! Steven, good to see ya! Welcome on in. We're at the very end, the bottom of the basic tutorials. I'm really excited. We're gonna do the test loop today. We're all familiar with this. We're gonna use model eval, and with no grad, no torch. I don't like using with statements like this because it just indents it automatically, so I'm gonna use it differently. We're gonna make some adjustments. It's gonna be great. I'm excited for this. We're nearing the end here. Although good news, there's way more to go. We're nowhere near done yet. There's a lot to do. Then we're gonna have a lot of fun. Once we become experts with the tutorials, we've gone through everything and we've messed with it, we will be building some real models. Some real useful models. That's the part I'm excited about. And then we're gonna bump into like the next level of things. We're gonna take it a next level further after that. So we've got a lot of plans. Don't worry, like this is like months and months worth of things that are gonna need to be happening. Let's get into the testing. Let's make it happen. You can use no grad as a decorator. Yeah, let's do it as a decorator. Oh, over the test function, yeah. All right, I'm gonna do it right now. All right, def test. And we'll pass, and we'll say at torch.nograd. There you go. Can we do that? Is it like that, Neva? Like that? Can we do that? I want to do it like that. I like that. All right. Here we go. Just like that. Okay. I think. I'm pretty sure. Double check. Yes, it probably is like that. Okay. All right, let's write it. All right, data loader model loss function. We need the model. Okay, we need data loader. We don't need those things here because we have them set globally. We're doing this trailer park style. We don't need to put anything inside of our parameters here. Trailer park style. All right, let's test the accuracy of our model right there. Not sure about these parts, so like you might do this, something like that. Okay, without the parentheses. We'll try it this way. We'll see. It's not gonna. It'll tell us if we get it wrong only if this is a broken. Otherwise, well, because it works here like this. So although it is, yeah, I think you're right. Without the, yeah, exactly. Fizzy, how's it going? Steven, how's work as life as a CTO? We're doing good. We're making progress. We're innovating. We're working with the teams. We're working with customers, and we're now live streaming here on YouTube. Watching. We're doing some live streams on YouTube, you guys. Oh wait. We've got a different song first. Let's do this one first. All right, we bump into that one. Life is good. Thank you for asking, Fizzy. Now let's bump into testing our data. So we've got no grad here, test the accuracy model. So what do we have to do? We're gonna say model dot not train. It's the opposite, right? It's gonna be eval. Okay, we're gonna do model eval there. Basically, the arg is not none. It does one thing, and infinite it does another. Wait, if ninits? Wait, if ninits what? Eval. Yeah, eval. We got eval. Yeah. So we got no grad. And we got eval. So that way, this prevents any of the regularization level thing, the dropouts. It disables dropouts and things like that. We don't need it because we're not using any of those things. Hey, Tom Hawk, good to see you. Welcome on in. All right, you guys, let's get bumping up here. So we are going to, all right, so we need a little bit of data here. This is going to be a little bit of setup. So we need the size of our data. We need to get our test data though. We need to pop in our test data. We haven't loaded any test data yet. Where is that? All right, so we've got a data set here. We're gonna go test. We're gonna make this a test here. Test data set, train false, and then let's clean up. Let's do some cleanups here. Tom Body, are you okay? Tom Buddy, are you okay over there, Tom Hawk? Like how you said that. Never. Okay, we're gonna delete this because we know it's busted. Clean up that. Okay, so now we've got our test data. Then we don't need that anymore. We need to test data loader. We're going to pull in our test here. Test underscore data set. Batch size. Do we need batch size with this for the test? Do we need batch? We'll do batch size. That's fine. We don't need a shuffle. Fizzy probably is a bot. Oh, it might be. Oh, let's hope it's a bot. Yeah, exactly. Let's hope it's a bot. Okay, you guys. Happiness. Here we are, making our way, cleaning up some of the debug statements that we no longer need. We never use this. Are we gonna need it though? At this last moment of time, are we gonna need it? I don't think so. I don't think we're gonna need it. We'll leave it there just in case. Okay, now we've got our train function, model the test. Then we're going to get some, how do we want to do this? X, Y. Okay, so it's the same as up this. Okay. Do we need to enumerate it? We don't need to enumerate a data loader, right? Oh, we only did that for progress. Okay. Okay, got it. That's good to know. Okay, so let's do this. For X, Y in test data loader. Do something. All right, we're going to do a output equals model X. Okay. Do we need, we don't necessarily need to calculate the loss here. We can just see whether it got it right or wrong. Like this is unnecessary. We're just going to see, we're going to do accuracy and precision. Let's do accuracy and precision. Let's do both of them. We'll go all the way. Okay. Test loss, correct. So it does it. Okay, the tutorial is covering both cases. You should batch test and batch size can affect the results for some ill-informed measurements, such as some definitions of perplexity. Let's learn together, you guys, what perplexity is. All right. Perplexity definition. Okay. A inability to deal with or understand something complicated. Oh, really? Wait, hold on. Wait. Is that all that was? The inability to deal with or understand something complicated or unaccountable. She paused in perplexity. That's it? That's all it was? Really? Why not just say complicated? Or something like that, you know? Steven, do you have ADHD? Oh, you're always up to something, but you finish half of the crypto. Oh, right. We never finished the crypto project. You're right. We didn't. We moved on to something else. We got distracted by shiny things. We did. Chad is here. Hey, Chad. Good to see you. Welcome in and happy Friday. If coding is your power, then what are you without it? Well, so like, it's not much different than saying like what an artist does. There's a lot of artists in the world that have fun painting pictures. Most of them, like 99% of artists, can't make a living on it. Only the top 1% can. They still draw for fun, right? We're doing that for fun too. Although it's a lot of fun learning the technology, there's still an advantage to understanding how systems work, even with AI being able to write all the code for us. Even the AI being able to draw pretty pictures for us or make videos for us. There's still a lot of fun in the art. In the making. The art in the making. Perplexity in machine learning means the sum of log p. Oh, there's an actual function for it? Never. Divided by the number of tokens including masks. That's the perplexity. In machine learning, really, perplexity in ML. It's an actual function. It's an actual function. Where is it? Where is the function? Deep dive deeper. Give me the equation. The equation. Give me the equation. Pee Wee Herman, I thought you... Oh, yeah. Hey, that was going there. The on Nira Di Nicola. Don, how do you see your? It's good to see you. Welcome on in. Hey, Sad, do you have any courses? We do. We have one course in Rust, although I don't know if you're interested in it. We have one full, complete course for free in our courses right here called Rust. Right there, you guys. Rust. It's Rust. Rust for beginners, and we go through 37 lessons. It's pretty good. It's pretty good. Steven, you want to find it on Google? It has multiple contradicting definitions. Okay, got it. We won't find it on Google. That looks like some perplexity equations to me right there. P equals a whole bunch of parameters with a 1 over negative n, which is the same as the n to square root 1 over p. Okay. Relationship with process entropy. Oh, there's a whole bunch. You're right. There is a whole bunch of different things. Look at this. All right. So weights equals expression, parameters, the sum of natural log, I guess. Oh, okay. It gives you a number. That's all we know. It gives you a number. Okay, you guys. Let's go back to our testing. Model test here. That part of including the mask took me a week to figure out because no one specified it. Really? Oh, okay. Perplexity with the including the mask. Including the mask. This is not how we actually compute for NLP when we have batches. Okay. Well, we're going to do some very basic testing anyway, at least. Although it would be nice to be able to say, generate me the perplexity for the output of the results here. Okay. I want to do a couple of things. So let's do our losses. Let's do our... so we get all the losses. Let's do accurate. Let's do... How do you want this? Answers equal another array of answers. So we'll have correct and incorrect. So we'll put correct or incorrect. It's Boolean in this. So this will calculate total number of correct answers. And we'll define it by correct by sort of rounding up is what we'll do. And this is the sort of the accurate, the precision. Precision. This is accuracy. This is precision. Or the cost, right? This will be the cost. All right, so our loss equals the loss. Do we wait? Model dot loss. Do I have to say to device? 1 second. Yes, we got to do this. We forgot a step. We forgot a step. Right here. There we go. Probabilities divided by probabilities.mean -1 right labels.mean. Wait, what is that perplexity? Is that perplexity for what we're doing? This is basically how you calculate the sample perplexity. Oh, okay. I've never done this before. I don't know what it means. But I'm going to copy and paste it and maybe we'll use it today. Here we go. Let's copy and paste it. Perplexity. All right. Let's see if we can do that. So probabilities over the mean of the probabilities. Right. The correct labels in the mean. So it, or at least how we did it on your paper. Okay. Got it. Okay. Does perplexity mean the possibility of accuracy? For example, we don't need to actually run it through any testing or training. We just need to see. Thank you for the heart, you guys. Thank you for the heart. Does it mean that we can calculate the perplexity of something without actually running it through a model? It's just the total number of probabilities. Is that what that is? And then what is right labels? I don't know what right labels is. I get the probabilities, I assume. No, you do need to run it on data. Okay. Okay. We'll have it up here as a to-do item. Right here. To-do. All right. Make sure to do to-do perplexity. I want to do it. I don't know how to interpret it though. Whatever the answer is, it gives me an answer. I've never seen the results before. I've only done accuracy and precision. So Let's do our losses or even precisions. Yeah, precision. Precisions! I like it. Total number of correct answers. We get our accuracy. It's basically how close is the predicted probability to the actual answer. Oh. How close it was. Okay. Right. Got it. Okay, so that means that it's closer to the precision level of things rather than the accuracy. Accuracy tells you how many times you got it right. Does it count as a right answer? Because you can be close and close enough to be counting as right. However, how many times there's also how close you are to the actual answer, which is essentially perplexity. And that's what I'm using this as a proxy. So this might be pretty close because I am going to use a mean. I am going to average it. And I'm giving the subtraction. Okay. Which is basically just the cross entropy. Oh, it is the cross entropy. It is the cross entropy. Which then in case this is our loss function. So they should be very similar is what you're saying. They should be very similar. Okay, so let us do the... I'm curious here, before we do this, before we run our training, we're just gonna do the testing. It's gonna get it all wrong, which is fine. We don't care that it get it wrong. It's fine. So that's the output. We should do argmax is what we need here. Argmax. Hey, we don't have to do any rounding. Oh, this is great. Out.argmax. I think the answer, or the label answer equals. And then y is going to give us the actual result. Hey, how's it going there? Sujit Edge. Sujit, I'm trying to say, thank you for saying hi. Welcome on in. Good to see you. Almost like plus some constant that it depends on the distribution and not the model. See, that's what I was wondering. That's kind of what I was thinking. I was wondering about that. It's the distribution is what it looks like, because I don't see any input outputs here. I just see the total classes, right? The total categories. These are the categories or the classification possibilities, correctness, and the average over it, which gives you a constant number, right? So even if I train the model, see, this is what I don't understand. Even if I train the model and it gets better and better, this number never changes. Input is the logic probabilities. The probabilities. Okay. Hello, sir. Hey, Mr. Dungwall, good to see you. Welcome on in. Happy Friday. We are going through our Pytorch expertise tutorials. We're going to go through every tutorial. We are at the end of the week. We are doing very good. We are at the test loop. We're here at the test loop. And we're making it our own. We're doing different things. Argmax 1. As predicted by the model. Oh, it has to be predicted by the model. Talofa. Hey, Talofa. Falima, thank you for saying hi. Welcome on in. What is that, Talofa? I don't know what that is. Is that a good thing? Anyway, I would show an example maybe later from actual code we use in the paper. Oh, that would be great. Neva, that would be great. I want to try it. I've not used it before, and I want to be able to get value from perplexity. That's something that it interests me. It deeply interests me. All right, so there's our answer, or our label, and then we can say what it thinks it is. The what do you call it? The name? Maybe we'll call it the name. What was this over here? The label array. Okay. Label array answer. There we go. So then we can say what we think it is. All right. Print f model guessed, and we will say name. What is the name of the theme? The theme. Oh, Zoid. Zoo Idiot. Oh, Zoo Idiot. Hey, how's it going, Zoo Idiot? The name of the theme? Oh, this is Groovebox. All right, at Zoo. This is Groovebox in Vim, running tmux in ghosty. There we go. There you go, Zoo. Steven, we're doing good. Hey, Steven, how are you doing? We're doing good today. Thank you. Yeah, we're going through the end of our tutorial here. Let's open this back up. Custom data. Thank you for the hearts, you guys. Appreciate it. Welcome on in. Happy Friday. All right, so there's our answer. And the model guessed the actual answer is actual is going to be the Y, which will be, let's say, actual. Yeah, I'm going to say actual name is going to be label array. We will do Y0. Is that it right there? Wait, this is batch though. This is batch. Wait, we've got a problem. You guys, we've got a problem. Wait. We got some problems here. Hold on. We can't do that yet. Let's go print out. We're gonna have to figure this out. Thanks for the answer. Yeah, no worries. Thank you for asking. Good question. Okay, so this is gonna be a batch of 64, I believe. And so I want to look at that to see what it looks like. So we're going to say return here. So we're going to see what one batch looks like. Here we go. This shouldn't crash. Oh, wait, it didn't even print. Oh, because we didn't run test. Okay. Test. There we go. I gotta execute it. Oh yeah? What font do you use? This is called, it's a mono font, obviously for coding. JetBrains Mono. It's called JetBrains Mono. So it's at Zoo. This is JetBrains Mono. Okay, so here is the answer. Let us run this argmax. Let's run argmax on this. So answers. This is going to be a bucket of answers. This is 64 answers. So we're going to print answers. There we go. Let's hide that. Bring this down over here. Okay, thanks again. Yeah, you're welcome. You're welcome, absolutely. There we go. Isn't that a lot easier to read? That is a lot easier to read right there. Do we have anything in the 9 range? That's what I'm worried about. Well, it should be 10. We should see 1 9 in here somewhere, right? We should see a 9, at least 1 9. Is there a 9? I'm only seeing 8s. That means we've got a problem, right? Because there's supposed to be 10. It's a classification of 10 items. I'm not seeing any. There it is. There we go. We got a 9. All right. So we've got our answers. We got our output. Now, let us get. We need to create a function that's going to give us. If we essentially need a map, we need an array map of true false, and then we can append. Or concatenate. We'll concatenate on this. Okay. So we've got our answers, and then we need to see map. Let's see. Correct. Equals map on our answers. Answers. And that how do we do this again? Is it lambda, and this, I believe, right? Map answers lambda. Hold on, let's do this real quick in Python. So let's see. This is we'll do map 1, 2 lambda a, b print. How about we just do this? We'll just say a, b. B is not defined. Yeah, it's right there. What do you mean B is not defined? Maybe we have to do this. Lambda expression. Can't be parentheses. Yeah, that's fine. How do we do? Oh, how's it going there? Hey, thank you for saying hi. Disease. Good to see you. Welcome on. Kim Ho. We'll call you Kim Ho. How do we do multiple in map for when to the lambda? How do we do multiple? Haha. you figure, yeah, exactly. B is not, it's right there. B is right there. It's definitely defined. All right. What's good to do? All right, let's do this real quick. Go code. Let's how to, all right, Python lambda multiple params example. That's what we're looking for. A real quick and easy. Yes, very something simple. You're asking for Python lambda with multiple. Yes, that's what we're doing. It's right there. Right? Look at that. Iron. That's what we're doing. It was exactly that. All right. So let's do this. Okay, so we'll say my is it pass? We'll call it pass. P equals lambda a comma b. It's still a problem. So can we say return invalid syntax? Yeah, I know, because it's a lambda. You're supposed to do this. What if we put this in parentheses? There we go. Okay. There we go. Much better. Hey, bro. Oh, hey, man. How are you? We're doing good. Rohan, welcome on in. Good to see ya. We're doing great. We're becoming Pytorch experts. We've been using Pytorch for many years now. We're going to go through every single Pytorch function and all the tutorials so we don't miss a thing. We're going to become deep experts. Let's do it together. Let's become experts. Hey, Claude, good to see you. Hey, bro, how are you doing? We're doing great. We're at the very end of the tutorial over here. So this will be our AI. We'll say here. This will be the codex. Train Vim. Okay. How you know how to code Lua? Oh, Lua. Yeah, this is kind of like Lua, right? This is Python. It's very similar to Lua. Although Lua has, base 1 indexing, which is fine. It's a little annoying, I think. It's like the one annoying thing with Lua. It's got their tables and dictionaries are weird in Lua. I'm not really a big fan of how they've done the tables and dictionaries. I think you could have made it more concise. Python dictionaries, okay. JavaScript dictionaries, even better. It's your 9th like. Oh, great. Here you go. My 9th like. Thank you, Claude. Appreciate it. Happy to have you here. So this is going to be correct answers, map answers. This will be A, comma B. We're going to return A, comma B. And we're going to see what correct looks like here. Print correct. Perfect. I need the index number is what I want. And then what I can do is I can take that with their labels and then find out if it's the actual answer. Okay, here we go. Thank you for the heart, you guys. It is not invalid syntax. We just proved it. We just proved that it wasn't. All right, so let's see here. All right, we'll do our process. I don't know what to call this. There we go. Proc. Eval. I'll call it evaluator. Okay, now we should be fine, right? Now we should be fine. It can't be angry anymore, right? Pretty sure. Okay. No, it's not fit. Oh, I see what it is. That's what it was. You guys, there's an extra colon right there. There's an extra colon, Steven. What are you doing? Extra colon right there. Whoops. Function object is not iterable. Where is that? Answers or evaluator? Map example. How do we do this? Python lambda map. We're gonna try this. P. Okay. So it goes the other way. P comma. All right. What's the opposite direction? There we go. Okay. Much better. Hey, Dina, good to see you. Whoa, you're streaming again. Yep, we're streaming again. We're going to make sure to go through every single Pytorch tutorial. We are almost there. We've almost completed it completely. We're running through the test phase now, and we're making it our own. We're following along somewhat. And we're going to be making some adjustments as we go. A little bit of adjustments. This is neat. Okay. I like this right here. Correct. In the batch. Coding is hard. Sure is. You sure is, Keemho. It sure is. So I think the perplexity in most papers is just log softmax.mean, ignoring mask completely. Okay. Log softmax.mean. All right. I'm going to copy and paste that. Here we go. Perplexity. All right. Right there. Easy. Easy. Thank you, Neva. I'm writing a mini Pytorch in CUDA C++ to understand the lowest level of AI machine learning. Dina. Now you're going into the tricky mode, right? You're going into the more challenging aspects of it. Going straight in. So you're going to write your own kernels. They call them kernels. They're essentially, compute shaders. Is that what you're doing? You're writing your own compute shaders? I've done that a few times. Maybe there's an exponent after it, so .exp. Okay. Sure. Why not? Just multiply it by itself. EXP after. Why not? Make it bigger. Okay. We're gonna answers. Okay. All right. Correct answers. All right, let's run this. Oh wait, we just have math, so we should probably do enumerate. Something like that. Maybe. I think. Maybe. No. We want to do something different. I've got an idea. Yes, here we go. Okay. List. Yeah, there we go. Ha! Ha ha! Ha ha ha! CUDA equals kernel. CUDA is the framework for writing, I believe, kernels to run as parallel compute little bundles of code inside of GPUs for NVIDIA, specifically NVIDIA GPUs. Yeah, you've written a few kernels and you've got some basic neural network working with some learning and good predictions. Nice. Wasn't it great to use the threads as the transposition? To use the threads when you do X and Y thread, and then when you want to transpose the other matrix, so you got two matrices when you're multiplying them or doing some other operations, to transpose them, you just flip X and Y. Wasn't that great? I'm like, that's my favorite thing. That's what I did. That's how I did my CUDA core. CUDA code that runs on GPU is called a kernel. It is called a kernel. Writing CUDA is fun. I've never got to actually using the CUDA libs before. Never. Very nice. Yep, we've done that. We've done that. Was that maybe like 4 years or so ago, maybe? I don't know. All right, let's see if this does a trick. Let's see if this does the trick. Oh, we got to do this the other way around. There we go. Nice. It's got to be the evaluator and then the data. Oh, wait, just kidding. Hold on. What's the problem? Okay, so that's not a problem. So let's print out the answers real quick. The evaluator. Yeah, working in threads and cooperative groups was a stressful but fun when they started working, and it sure is. You're describing how software engineering works in general. It is. Because it seems like high stakes when you're programming in the CUDA world. It's like high stakes. Because if you make a mistake, it feels like it's a catastrophe. I don't know why. I've done this. I've done this as well. Whenever you're coding in CUDA, it feels like the stakes are very high. The annoying thing is the threads are limited based on the GPU. Got it. One thing I really wanted to do was a 3-dimensional matrix multiplication, basically a full cube, in one round, passing in a 3-dimensional vector and another two 3-dimensional vectors, and doing a full matrix multiplication forward pass in one giant CUDA blast. I want to do that. I think it's going to be really, really neat. It'll just be accelerated. It's just extra. It's like you pump the data over to the texture memory once, and then the GPU just burns as hot as it could. What if the CUDA AI have created its own world? We don't know. Theory. Well, you're talking about there's probably some sort of sentience or consciousness or maybe a universe. I mean, maybe. I don't know. I feel like no, but maybe. I don't want to disprove anything at this point because I can't. So you can make a 2D mult with a 3D thread using remaking the index. That sounds like exactly what I'm talking about. Yeah, that sounds like exactly what I'm talking about. Never exactly. I really want to do that. I really want to do that. I think that would be a lot of fun. We'll do that eventually. We've got so many streams ahead of us. There's so many days, so many live streams to have, so much content to cover. We'll do kernel programming. We'll do kernel programming. Right now, we're just going to try to get this AI function to test itself. But yeah, they're just a CUDA math mult that's optimal. There's already one that's ready to go. Yeah. What I like is fused kernels. So the reason why I did it in the first place, because I wanted to accelerate a pretty large project. I wanted to fuse kernels. See, there's a kernel that does matmult. There's a kernel that does XYZ. I wanted to merge all the logic together, including activations and everything, all in one big giant kernel, a mega ultra kernel. And it made it so much faster when I did it. It really did. It was great. It was like so much faster. Isn't this just batching? So each Z thread will be another set of XY matrices? Good point. You could do that, right? That could be through a batch, right? So instead of doing one at a time, you could do batch. So I'm thinking more of it from an inference perspective, when you typically only have a batch size of one. And if you could do that, that means you could use the Z thread for a 3D matmult feed-forward neural network with a mega ultra kernel. And that's an inference optimization. I think it would be amazing. I think it would be a lot of fun, and I think it'd be innovative. I feel like I'm not the only one in the world to have thought of that. Or you mean something else? No, that's what I mean. Yeah, Dina, you're on the right track. You and I are on the same page. Doing softmax with cost entropy can go vroom by using custom logic. Oh, it can go real fast. Yeah, when you have your architecture down and you can write your own kernels, and it's... Exactly, Dina. You know it. Exactly. All right, so why the deal here? Answers. All right, so wait, let me sprint my answers real quick. All right, so instead of doing this, let's go over here and try this. Let's go this approach. Okay. So apparently we can do something like this to get our correct answers in an array. So we can get an array. Let's try this. Let's just try that straight up. Correct is going to be, I'm going to just comment this out for now. Correct equals our output minus our correct answer. No, equals Y. Okay. That right there. It looks weird. Don't get me wrong. That looks weird. I think it'll work. Like if you do the math, it works to be selected log xping sum all. Oh, sorry, not. Oh, like if not. Okay, got it. Hey, Steven, Michael, how's it going there, Michael? Hey, Steven, do you ever talk about what you're working on outside of this? Anything cool or exciting? Yes, I do. I sure do. We'll bring it back. We will. There'll be a time. When we do that. And we actually are planning it. It's coming up here pretty soon. We will be doing a lot of streams that talk about more of what I do in my day to day. So it's going to happen, Michael. It'll happen. Stay tuned. The plan is in maybe a month or so, maybe around a month. I heard your meeting reminder a few minutes ago. Oh, don't worry. And that was, yep, we're good. What a tease, Michael. It's going to happen. I promise it will in the future. And we will dedicate entire streams to it. So it'll be a lot of fun. What are you doing? Videsh, good to see you. Videsh, welcome on in. Happy Friday. We are wrapping up the final part of the Pytorch basics tutorial, the introductory tutorial, which are anything but basic, it feels like. The good news is there's a lot more tutorials to come. We're nowhere near finished. We've got like maybe another month of tutorials, and then we're going to start building. Once we become Pytorch experts, we're going to do that live on this channel, live on the stream. We're going to become Pytorch experts. Once we do that, we're going to start building some pretty amazing projects, and it'll be a lot of fun. That's going to be fun. We're going to do it, you guys. All right, let's see if this worked. I'm pretty sure that'll work because I just read the code and it seemed like it'll work. It's supposed to, hold on. Expected all tensors to be on the same device. To model.device. There you go. Is it better now? You like that better now? Okay. Same device. Boom. Yes. Yes, yes, yes. Okay, perfect. This is what I was looking for. They can't all be wrong. There's got to be one random correct answer. There's got to be one correct answer. Let's try it again. Let's try it again. There's got to be one true. They can't all be false. There's no way. No. All right. So maybe what we have to do is we have to do something else. Okay. So this is going to be... Okay. I see what's going on. These are batches. So, but it's a batch of... It should be pretty straightforward. So we'll find out. We'll find out. Bro, hear me and so hear you out. Some people know. Some people guess. You're talking about startup thing. If you know, you know. Suspense planning from Stephen Blum. Yeah. You know what we're doing. Yeah, exactly. It might, I mean, it actually technically is. You're right, Claude, technically you're right. It is going to be a little more surprise and a little bit more nuanced. Technically, you're spot on. You're spot on. All right, I want to print my out. No, I've already got my out with my answer, so I don't need to reprint it because I already argmaxed it. I already argmaxed it. Do we need to do the same with y? We do. We do need to argmax it as well. The argmax 1. There we go. I think. Let's double check. So we'll do y dot argmax 1. I think. Like that. Should be fine. Okay. Let's try that. Okay, so... Yeah, that looks good. That looks correct. Okay. Yes, yes, yes. Happy. Okay. The size of tensor 10 must match the size of B. 64 is not a dimension, not a single dimension. Okay. All right. 1 second. So this and this look identical. So let's print that out real quick. Let's double check. Likely the most important question of the day. Keyboard and mouse setup. All right, you guys. There you go. There you go. Keyboard and mouse setup. Well, you got one with the number keypad on it right there, so you get the pretty numbers. Right, you got to press the numbers. Pretty numbers. And I've got a magic mouse. There you go. Now you got the answer, Michael. You got the answer. Very simple, very basic. Low profile, clean. There it is. You got it. There it is. Okay. So we've got our Y. Let's print out. So we go. Oh. Nah. We need that. Is that better? I think that'll be a little better there. We could do that. Think. Oh, I have the same Vim thing. Oh, you do, Claude? Wait, really? You have the same Vim theme as you. So you'll open up a terminal, run that file, and use window. So you guide. You have not installed any terminal inside Vim. What do you mean terminal inside Vim? What do you mean terminal inside Vim? You mean things like split screen? So you can do split screens and like have multiple things happening multiple times? Like, what do you mean? I think Pytorch cross entropy is a fused kernel that purposefully gives the wrong answer the same grad to avoid using an exponent, exponential or exponent. Oh, really? It's actually purposely wrong? I'm kind of curious about that. What do you mean? In you background, my favorite song mission to Mars. Oh, is that right now? Is that what's playing? You're right, it is. Right there. Mission to Mars. Let me try to zoom in right there. All right, mission to, it's right there. Mission to Mars, right there. Right, yep, you're right. It was Mission to Mars. You got it. Good ear. Good ear. Code like nobody's watching. I know, Code Lucky. We're gonna do it. But you might need to do it yourself, maybe. Okay, sounds good, Neva. We'll figure it out. Right, here we go. Yeah, split screen terminal. Use tmux. Use tmux. Tmux at Claude. It's called tmux. Okay. Okay. Let's get going, you guys. We're coding like nobody's watching. I'm happy with that. That's perfectly fine. Y will it not let me go a different direction here? I would like to, maybe what we could do is we can just pull the data out. So we say out dot detach dot CPU, like that. Out. Oh, out. We need to do out. Okay, we've got our answers, which are out right here. So where's answers? Answers. We already did this. So our answers will be. So we should do this. That's why, you guys. That's why. Detach CPU, and we'll say answers. There we go, like that. Now it should be good. Have you used CMux? Oh, I've not even heard about that, Code Lucky. I've not heard about CMux. I've only heard of TMux. Okay, got it. Thank you. You're welcome, Claude. Now we should be good, you guys. Okay, so we get answers, and we don't need the 2 device here anymore because that's already on the same CPU device. Okay, let's try this. No errors. No errors. What? One. Okay, hold on a second. Missing 1 required positional argument B. Oh, we're not using that. Why did I uncomment that? Oh, we don't need this. All right, we got it right. Now, no errors. Hey, Loons, good to see you. Welcome on in. Happy Friday. Hey, look at that. We got an answer that's correct. Whoops. What? You didn't see nothing there. Okay. I want to Pytorch that. Let's grab that. Let's grab this. Okay. All right. Hey, Loons, welcome on in. Happy Friday. We did it right there. We got some. All right. So now that we've got our answers, right? We're making it our own, right? So we turn this line. That line right there, that nice little clean line that you see on the screen right here, we replaced it with this line. So we're making our own. We're making our own. It's so good as we're making it our own. All right, so we want the loss as well. Let's do losses equals. We are going to do model.loss. We're going to say our out, comma, our y dot to device model, like this. Model. There we go. Shouldn't you code like everyone is watching? So you're right. Good code. Yeah. Well, I mean, yeah, that's a good point, right? You could like make sure everyone always code in the best possible way you can code, whether you're being watched or not. Okay, I think we've got a good result. So we got our losses here. Let me print that out. Print losses. There we go. Let's see. That should give us a nice answer. And then we're going to convert that up to here. Although this is shadowing, so we need to precision. And then we've got our answers here. Our precision and our answers. All right, good. Okay. Let's print that. We should be happy. CMux plus OpenSpec, both are open source and are really, really cool to work with. CMux. You guys are CMux. Okay. We have a little, oh, here we go. Semi issue. Little semi issue. Perfect. That's what I'm looking for right there, you guys. Although, did it print the losses? I don't see. This should be different. I should see some floating point numbers. I see some floating point numbers. Why am I not seeing floating point numbers? This is wrong. Something's wrong. What is the deal here? G? Custom data set? Did I do this right? Are we ready? Are we running the right thing? Why is it not printing this? Right here. Right here. It should be a bunch of floating point numbers. All right. Print. We're gonna. Low. All right. We're gonna make sure that it's actually the right one. It's okay. Oh, Steven. The answer's here the whole time. The loss and the cross entropy is going to be a single scalar value. You should have said, Steven, it's right there. It's right there. It is working the whole time. It's working. Okay. So let's go our precision. How about this? I like this better. We'll do cost calculation. Cost. We say loss. We'll go cost dot append loss. Yeah, try that. And then we'll do an average over it. So we get our, how close we are, how good we are on it. It'll be good to also make a long form stream, not only shorts. We do. I've got good news for you, loons. You get right here. We got ourselves a long form stream. Where's that at? That's over on Twitch. Eventually, we are going to go full on YouTube. YouTube has a problem right now. So what you do is you go Twitch/StephenLB. And you can see right here. There you go. Look at that. There you go. Look at that. Wow. Wow. Pretty good latency. Wow. Pretty good latency. Pretty good latency. All right. There you go on Twitch. If you're interested, it's there. Great job, Stephen. Hey, Lucky Code. Thank you. Thank you. Appreciate it. Great feedback. All right. Let's keep going. Let's keep going. Let's keep coding, you guys. So we got our cost. We're going to put the loss over there. And then we're going to, once we're done with all the evaluation, we'll pop out. So we get our answers. So now I need to get our answers there. So our answers will be in this format. And then we should do a concat. Can we do some sort of concat? If this is our answers right here. Steven, can you do the echo? It works very well with your music. Wait, what do you mean? The echo works very well with your music? Oh, then what do you mean? Hey, Loons! Oh, Loons, I didn't... Oh, you followed me over there on Twitch. Hey, thank you, Loons. All right, let me tell you. Say, hi, Loons. Over there on Twitch. Good to have you there. Thank you for the follow. Appreciate it. Can you do the echo? It works very well. Oh, can you do the echo? Yeah, the echo's actually pretty good, right? What do you want me to redo it? Like describe it. I'll make it happen. It'll be good to also when you put the stream twice on the screen, it echoed. Yeah, it echoed, right? That's how it works. It's because it's a replay, right? It's a replay. You're hearing it through the desktop audio feedback, right? Here. Wait 1 second. Pause the music. Okay. 1, 2, 3, okay. 4. 1, 2, 3, okay. 4. 1, 2, 3, 4. 1, 2, 3, 4. Yeah. All right, we did it. Yay! There you go. Not a big deal. Could be managed. I think it's good. I think it's the right way. I think we're making things happen. Yippee! Yippee! Okay, loss function, the item. Let's do that. Let's grab that item. Okay. So that works there. Let's print our, where's that at? So we got our cost. Got our cost. And we got our loss. Great. We've got our correct. Okay. Looks good to me. We got our dot item. Nice. Yeah, there we go. What happens if we do correct the item? What does this do? Does that make it the way we want it? Does it make it better? No, it doesn't like that. It's like, nope, you wanted to do that? Nope, sorry. Detach.cpu. Like that. Okay. Add Steven. Well, yeah, what's up? Yo, hold on a second. Correct. Oh, okay, correct, yeah. Oh, we have to detach as well. We detached it right there. Cost. Okay. We're making sure we got everything in the right shape. All right, looks good, looks good. The top one does not look because it's not a tensor. We don't want it to be a tensor. We detached it. What's going on right there? Correct should be detached. We detached it, y'all. Numpy, can we do that? Is that better? Does the loss? There we go. NumPy is better. Let's do NumPy. It wanted NumPy. Okay. Oh, because it's still a tensor. It's still a tensor, even though we did CPU. Okay. Man, best habit is to make your journal what you say. Best habit to make journal is to make journal. What is that? What do you mean? Are you talking about like writing in a journal? Does the loss have to reduce as a mean or a sum? Oh, yeah, we're going to do that. We'll do that. Yeah. So we're going to capture all of them, and we're going to calculate it at the end. We'll do it calculation at the very end. We'll make it a little bit at the end. Yep. You're right. It's going to happen. That's why I'm putting things over here. So then I'm going to do an actual number, like a total answers over correct answers, and we'll do like a reduce on the number of true values. So we'll run reduce on answer. We'll reduce. Oh wait, reduce. Oh, wait. Filter. We'll do a filter. We'll do a filter on the answers. Okay. Hey, Savon, good to see you. Welcome on in. Happy Friday. We're doing our test phase here. You're talking about making journal writing habit. Yeah, okay, got it. Yeah, writing in a journal, what you say on this. Yeah, that's fine. I don't know. I've not done it, so I can't give you an opinion on it. Code Lucky. Steven, are you partying this weekend or coding? Silly question. Probably doing house chores and playing Minecraft. Probably house chores in Minecraft. And maybe some other things like, paperwork. Loss usually means by the default, so you need to override it, the sum, and then count samples. Yep, to get the true measure, the mean. In practice, the difference is so small we don't care. Good to know. Good to know. We'll make her. That's a good point. So we could calculate it over time. We could. It's just there's not a lot of numbers. So we could do like a full loss and then average it over time. We could do that as well. So then we don't have to give ourselves the full resolution there. Basically, specifically the last batch has examples weighted a bit more. Okay. Can you suggest some good embedded systems firmware projects using C? Isn't it like ESP32? That's a pretty good one, right? And from a project perspective, add a photo sensor array. So a camera, right? A photo sensor array, added a camera, and then add computer vision on top of it. Some sort of computer vision. It's usually the most impressive. Whenever you add computer vision together with a project, you get like a camera of some sort and an embedded RTOS running like an ESP32 with multiple cores, which would be great. You could do on device. Do it on device, not off device. Do it on device, on the embedded device directly. Computer vision, you can do it. You can do it. Write a bootloader for MIPS. That's also the MIPSy, the MIPSel. Savon's got a good idea there as well. Okay, let's keep going, you guys. Am I getting what I want? Yes, okay. How about we do this? Correct, incorrect. We'll make it simple. We'll make it a little bit simpler. And so we don't need answers anymore. And then we will say correct. And then for each batch, we'll calculate them directly. So let's Okay. We can't call this correct though. We have to rename this variable. Each sample is weighted as a 1 divided num batch times samples in batch. So specifically for the last batch, it's weird. Oh, okay. If you have something like NLP, which had variable length samples, which you will in NLP, right? Because you're running over text. We need to change this variable name. What are we going to call it? We get our answers. We're going to output, we get our answers. And then we're getting the accuracy. Okay, accuracy. And then we need to do a filter. Let's run this over here in Python real quick. All right, so filter at the start, list, end, filter. We'll go one. Wait, it's got to be lambda a, and we'll say a. We'll just return a, comma, and we'll go true, false, false, like that. We have to. We didn't quite do it right. There we go. Unmatched. Yeah. No. What do you mean unmatched? Thank you for the hearts, you guys. Appreciate it. See, my brain is like potatoes mesh. Oh, due to the last 2 weeks, Savon. Sorry about that. Yeah. Thank you for the reactions, you guys. Appreciate it. floaty heart icons and all the faces and the party poppers. Appreciate it. Good to have you guys here. All right, let's figure out what we did wrong on this. List, open, filter. Right here. That's what's going on. There we go. Yeah, that's what I want. And we go, can we do this without list? What does that do? Okay, perfect. Okay. List. What if we say count? Can we do that? Count. Oh, Lin. It's called Lin. There we go. Lin. All right. Can we do it without list? Wait, hold on. Lin. Oh, right here. Here we go. Thank you for the party poppers, you guys. MIPS is such a fun. You learned how a specific processor works in school, and oh, it was so fun. It was nice. MIPS. MIPS is the way to go, you guys. It's the way to go. Thank you for the party poppers. Object filter has no length. Okay, so we do have to do list. We have to do it like that. Okay. This is the correct answer, you guys. Right here. Boom, right there. Actually, let's redo that. I'll grab every character. Every single character. Thank you, guys. Appreciate it. So good to have you here. All right, so we're going to be using this equation for our calculator. For the calculator, y'all. And then we'll just do a subtraction on the batch size. Okay. Hey, who's that? Who did that? Commander Diablo, thank you for subscribing. Welcome on in. You joined the right channel for software engineering. We build a Pytorch is what we're doing right now. We're learning all the Pytorch tutorials. We're going through every single one of them, and we're making them our own. We're reading the tutorial, and we're messing with it. We're not just copy and pasting. We're implementing it the way that we want to. Appreciate all the likes, you guys. You're making a good stream today. Good to have you here. On the last time of change your portfolio or profile to Claude. Oh, right. So after the people asking you to create things, they think that I am, it's just fun to take. Oh, yeah. Claude, yeah, I know. You changed your name a few times. More to know, just a few times. Love the tutorial. Get some Pytorch learning. Yeah, let's do some Pytorch learning, you guys. Who's that? Nasmo. Nasmo Gaming, thanks for subscribing. Good to have you here. Happy Friday. Let's see how the next hour goes. Yep, you know it. That's the next hour. We're here for at least another hour, you guys. So strap in. Let's learn some Pytorch together. All right, we got our Lin. We got our Lambda. Now, do we need our Lambda? Do we need it? It's just this. It's just going to be a straight Lambda like that. And we're going to filter. We're going to do a simple filter. Easy filter. And this will be our accuracy. There we go. Accuracy. No, not accelerator. Accuracy. There we go. Okay. This will give us the correct plus equals that. Okay. We should. I only want to run this once. I don't want to run this twice. So we should run it just once. Epic Blocks. Bo, welcome on in. Hello. I just joined now. I know just a few things about HTML. Hey. Well, we're doing Python AI. We're learning some Pytorch. We're becoming Pytorch experts, you guys. We're going to be Pytorch expertise. We will make it happen. Yeah. So basically what we're doing is what we've done here is, let's see here. We've got our data set. We've loaded it. We've trained it. And now we're doing the test loop. We're going to validate how good the model is on data that it's never seen before. That's the whole point of AI. You train a model on a whole bunch of data, and then you give the model data that it's never seen before. Here's a picture of a cat. Here's a picture of a dog. And if it can correctly guess the answer, you've made a good model. You did it. You made it work. Stephen and Nograd, we need to detach. Oh, Stephen and Nograd, no need to detach. Oh, really? Because we're in Nograd. Oh, we didn't know that. Really? You don't need to detach? Okay. Detach. Let's get rid of those detaches, you guys. No need to detach. Learning new things. Let's try it real quick. Let's make sure. We're going to try it real quick. Python. Oh, wait, one. There we go. Custom data set. No attribute CPU. So, wait. Are you sure, Neva? Are you sure? Oh. Hold on. Wait. We messed some stuff up here. Yeah, basically there's no grad and to detach. Oh, there's no grad to detach. Okay. There's no grad to detach. So there's no need for it. Okay. Let's see. I mess some stuff up here. Hold on. Accuracy looks good. We run through it. We got correct. Let's just print correct and see how it goes. We'll just print correct. Okay. No, this is gonna be different now. We've got accuracy and correct. Print accuracy. Okay. Let's try that out. We're trying to learn. We are trying to learn the network to predict. Yes, exactly. It's a tensor. Looks fine to me. Okay. So we've got 1, 2, 3. Okay. So we got our values here. Perfect. All right, looking good, you guys. Happy to see it. Correct, cost, append. So this will give us an array of our current loss. We could change that up though. So what I'm going to do is I'm going to change that to a 0, and instead of appending, we'll say plus equals. Divide that by categories? No, divided by 2? Wait, how should we do this? Cost equals cost loss. It needs to be a sum divided by the total. So there's always going to be 2 in this involved. So just do like this. We'll try that. Let's see if that'll work. Okay. What is the best software for mobile? Epic Bloxbo? The best software for mobile? What do you mean? Are you talking about like an app or an operating system? Because there are different things there, right? There's also no inference mode, which a new different somehow does the same thing. Oh, there's a new inference mode. Got it. Which does no grad, and at the same time it does eval. So what is this inference mode? Let's check that out real quick, you guys. That's important. All right, inference mode Pytorch. Inference mode Pytorch. La la la. All right, so torch.inference mode. This context manager or decorator disables gradient calculation and tracking. This significantly reduces memory consumption. Yeah, that's already what NoGrad did. What else does it do separate? This speeds up computation because Pytorch no longer needs to store intermediate results. Yep, we know that part. Is generally preferred over NoGrad for pure inference, as it also offers minor additional performance benefits by disabling view tracking and version counter bumps. Tensor created under this mode cannot be used in computations that require gradient later. That's fine because it's the same thing as NoGrad. So we'll do inference mode. Hey, look at that. All right, Neva, thank you. Inference mode, everybody. Use inference mode now going forward. Do not use NoGrad, just use inference mode. It's a smidgen better. How do I start C#? Well, you open up a empty text file and then you write a hello world. That's a good way to do it. And then you can use something like CLang for a compiler. You can use, I believe CLang supports C#, right? CLang C# compile. Does that work? Does that work? CLang is a compiler front end for the C language family, and it does not natively compile C#. Okay, C# is strictly compiled using the Roslyn C# compiler or the Mono project compiler. Okay. C# compiler Mac or Linux. There we go. Linux, you can compile C# code using the official .NET SDK, which includes the Roslyn compiler or the Mono project, which I've done the Mono project before on Linux. I've not used Roslyn. NoGrad can be used inside the train loop for some parts that need it to remove the grad. Okay, good news, good news. So that Zach GT, download the Roslyn compiler. That's what you want. What are you working on? Just joined. Obscure, welcome on in. Good to see ya. We're wrapping up the Pytorch basic tutorial introduction. We're making it happen. Oh, Loons, I just saw your chat over there. What did you miss? Don't worry, we're still going through the inference mode. We're still doing testing. We're doing testing on the model. We're seeing how good it is. So you didn't miss much. You didn't miss much. You did miss though the inference mode. So if you're using Pytorch, Neva just gave us the update that the tutorial is out of date. It is. The tutorial has a lot of bugs and it's out of date. We're going through it. It's fine. We're making it work. We're making it work. The inference mode is what you want to be using going forward. And I like it. I'm happy. Also, it's easier to understand just because I know what that means. So do we need to use model.eval with inference mode? That's what I'm actually curious about. Let's see here. Do we need to use model.eval with inference mode? Model.eval with inference mode. Hold on. Do we still need to use model.eval with torch.inference mode? I'm curious about that. Yes, you still need to use model.eval alongside inference mode. Oh, come on. Why both? I just have one. Or something. Module as a model level switch specifies. Yeah, exactly. I know that. But also in inference mode, you don't need dropout or normalization either. So why doesn't it automatically do both? Come on, framework developers. Trying to learn assembly for regular expressions? Or RE or something registered engineering? Wait, what is RE? You seem cool. Subscribed? All right, Obscure, thank you. Appreciate it. Good to have you here. We'll be reverse engineering. Buried assembly for reverse engineering. That is actually quite useful. Got your system calls in there. Yeah, a lot of system calls with your assembly. Those are my favorite because you get to do a lot relying on the kernel to make system calls in your assembly with a simple couple of registers. It's pretty straightforward. Okay, so you still need to do model eval. What? Okay, fine. We don't need evaluator anymore. Cost correct. Okay. So let us go over here. I need to see the intermediate. We need to name this something. We got to name this something. I don't know what it is. What is this variable name here? All right. So this is the total batch correct answers. Okay, so we go correct plus equals batch answers, and then incorrect plus equals our batch size. Yeah, batch size minus batch correct answers. Okay, so that should give us the incorrect answers along with the correct answers. Let me double check. Yes. So this is always going to be 64 or whatever that value is. And this will be below that or exactly equal to it. So that will give us that. So this gives us our accuracy and then our precision right here, you guys. Thank you for the arts. Appreciate it. I'm glad you're here. Let me know if you have any questions of what we're doing. We are currently working on Pytorch, the tutorials. We're going through our training phase where we train the data. We got it good. We made a really good model. We made it better than the tutorial. We did better than the tutorial. Hey, Bra Manica or Machina. Bra Machina, thank you for saying hi. And we also got Nasmo Gaming. Thank you for saying hi as well. Good to see you guys. All right, let's keep going. So I believe this is all the things that we need. So we need correct. We've got our incorrect. Let's put this all in one line. Okay, so let's do an F string. Correct. Incorrect. Yeah, I knew it. Okay. And then our incorrect. Incorrect equals. Like that. Nice. Looking good now. Vi data. Oh, no, wait. What was this called? Custom data set. Okay. Vi custom. Okay. So that lets us see where we are there. And we'll also do an F string here because we want to be able to see what we're looking at here. We don't, not for accuracy. We don't need this anymore. We just need the cost. So F string here as well. Okay, thank you very much. Hey, Trix Roshan, thank you for saying hi. Appreciate it. Welcome on in. Happy Friday. Okay, I think that gives us, I'm not sure about this, but yeah, it'll be fine. Divided by 2, sure, whatever. Yeah, that's fine. Okay. Or, yeah, no. Cost plus. There we go. That's kind of, hey, Mark Lemon, thank you for saying hi again. Good to see Mark Lemon's here, you guys. Always got to say hi one time per stream at the very least. Mark Lemon, good to have you here. I recognize every time you click that button, every stream, I see it. Okay, so now we should have, finally, the results that we're looking for, unless there's a crash or, yay! Nice, okay, look at that, okay. This is exactly what we're looking for. Perfect. And then we can say our accuracy will have a final accuracy after the for loop. All right, so we will say now we can run through the whole thing. And then instead we'll do one, we'll do break, and we'll do our final output. So we'll say print, actually we'll do accuracy. It's going to equal correct divided by incorrect. Right? That'll give us a percentage. And then we say F string accuracy colon dot colon dot 2F like this. And then we put a percent right here. And we'll say accuracy. Like that. Very nice, very nice. Man, meet you on Monday. Oh, it was been a best stream in kernel and Pytorch, must say. Thank you, Claude. Appreciate it. Still looking forward to that game when you do it. Hey, Max, good to see you. Welcome on in. Happy Friday. We're doing some Pytorch today. We've got the Pytorch tutorials for the fashion imness. A bunch of pictures of clothes. A lot of pictures of clothes. We've created a model that works very well right here. A very good, very nice, very happy model. It's great. I'm enjoying it. We did it yesterday. Today we're running through the test data. We're doing the test data section. So let's get our accuracy there. Let me see if that looks correct. Does that look about right? Accuracy, 0%, because there were no correct answers. So 0% looks right. Let's run it again to make sure. Actually 0.2%. Oh, we need that. So that is 2%. Let's get some more with correct answers. Yeah, all right. So we forgot to multiply it. So we need to do 100 times, like that. Okay. Much better. Yep, okay. So now we got our accuracy, and let's do our cost. Print cost. Going to be, we just say straight up cost. We don't have to do anything else because it's automatic. It's automatic because we're running it on an average. Or I guess we'll just leave it at cost. We'll just leave it at cost because that's exactly what it is. The game thing can make much more time because I believe it's going to take a lot of time for quality. Yeah, it does. Games take a lot of polish. It'll be ready to share in Discord and DM. Sounds good. We'll be waiting. Ready to go when you are. Okay, I think that looks about what I want. Do I have anything else that I am interested in before we proceed on forward? We don't need that anymore. We don't need that anymore. So we've got our final answers. Looking good there. And you know what? The cost should also have... Let's do that here. This dot 2F. We can do that right there. Okay. Excellent. Excellent. Happy about that. All right. Great. All right. Looking good. Okay. Let's get rid of all our debug statements. I think we're ready to go, you guys. I think we're ready to go. See, that's going to take a while to run. Oh, just kidding. It was instantaneous. I was like, oh, this will take a while to run. No worries. Now we can train the model and see if we get some really good results. If we get some really good results. All right, there we go, guys. Thank you for understanding, man. Meet you on Monday. Sounds good. Best stream. I appreciate it. Loons, you should add the option of subscribing on Twitch. I want to use my Prime. Oh, I'm not a partner on Twitch. That's the problem. I would put the option there if I could. I would. Yes, agree. We when the partner happens. I'm a partner on YouTube. I'm not a partner on Twitch. That's why. That's the reason, right? Because there are not many Twitch viewers. All right, 742% accuracy. There we go. That's not correct. That is an incorrect answer. All right, where is that at? Let's see here. Accuracy, correct over incorrect. That, okay. That is, how do we do this? Well, very clearly though, 74, it wouldn't be 7%, would it? No, there's no way. Here, we also need to print out, we've got to print out the answers. We just have to. There's no way we can't without it. So we need this, print answers. We need that. We have to do answers. Numpy. Okay, let's do that. Okay. All right, let's see if we got a better result there. Better result. And now what we've done is, I believe, we've successfully tested our data, which is great, which is fantastic. We're also going to do the model loading and saving, and I think we have just enough time to do that. Just enough time today to do that, which will complete the introductory tutorial, and we will have finished it, and we'll be good to go. No! I typoed! Okay. I'm going to hide this real quick. Make sure, you guys. Yeah, okay. That's not what I wanted to print, though. So, it's very pretty. It's very pretty. It's not what I wanted to print. Let's see. I wanted to print... No, oh, well, I guess technically that's right. What I wanted to print was the accuracy. That's what I want to print. Right there. Let's do that. Can I do that? I'm pretty sure I can. Yes. Like that. Okay. Let's try that real quick. A small question, sir. Yes. Let's think about that. Let's think about the small question. Can you get a web developer job without CS degree? Learn code self. Yes. I've done that. I don't have a CS degree. I got a job, although that was like 30 years ago. Because we're old. I don't know about today, now that the world is saturated with engineers. There's a challenge. And there's a current frothiness of the market today where it is difficult to get a job because everyone thinks AI is going to take care of things for you. The only thing is, it's not going to be the case for very long. So I think in the long run, yes, we're going to see an explosion of demand for the need of additional engineers. There's so much code being written today by everyone, even those who are not engineers. They're asking the AIs to write code, and they are doing it. They're building things that work. It's going to increase the surface area for maintenance requirements, right? Hey, Redless Saber, good to see you. Welcome on in. Happy Friday. You can do it. You can get a job without a degree. You need to show that you're able to outperform the rest. You got to do that. You got to stand out. You got to stand out. Why did my accuracy look weird? Is it actually a percentage? Accuracy is going to be... Oh, correct. Right. Oh. Yeah, that's fine. Accuracy. What are we doing here? Batch. Okay, right. Okay. Looks good. We got a correct versus incorrect, which I could probably do just right here. Let's do it all in one line to make it nice. Like that. A little bit easier to understand. A little bit easier to read. It's a mindset. Swamp Rat. You know it. It's a mindset. You can do it. It takes a lot of tries, and it's very possible. It's a numbers game. Eventually, you'll make it in. Don't give up. It's almost a guaranteed failure for a lot of times until you eventually get it right. As you can see, even what we're doing right now on this stream right now, we are failing constantly. And you know what we're doing? We're persevering. We're moving forward and we're trying to make it better each time. Each time. All right. Correct divided by incorrect. It's going to give you an answer of 1. So I should have to multiply this by 100, right? Every time there is some sort of keystroke that I'm doing that disables syntax highlighting, and I don't know what it is. Okay. You think some companies will actually pay more for a human employee? Not a lot of people are actually learning to code and just vibe coding. Yep. So many companies would like to have human employees. Yeah, I mean, I think so. I think so. And I've noticed that even with a project, even with vibe coding, we're not able to make things go fast enough, any faster than what you're already capable of. And you still need to add more humans because they're driving the coding agents. It doesn't matter. The actual bottleneck was never really writing code that fast. It wasn't, because you had things like frameworks, React, Mongo for databases. You have existing systems that you pull in all these components together, and it takes care of 90% of your code for you automatically. And so you're writing that little bit of 10% code on top to bind everything together to meet your needs. And that's the acceleration we're getting. It's still good acceleration that the AI is writing the code to do that little bit of part for you. And you still need humans though. You still do. The thinking, the iteration, the testing. There's still a lot of work to do there. So we need you guys. Don't give up. Keep on trying. Learn another craft as a backup. Yeah, I know, right? Oh, just in case. Just in case. All right, let's see if that did what I wanted to do. Yeah, see, that looks correct. That looks correct to me. Okay. The only thing is, if the correct answers outpace the incorrect answers. So what we need to do is we need to get the total answers, right? The total answers. So use cost plus, correct plus. There we go. Thank you for the hearts, you guys. Appreciate it. Yeah, you're good to go. Hey, don't worry, everyone. We're going to need more engineers in the future, like a lot, not a little bit. More code than ever is being written right now by non-coders and by professional coders. We're just going to need more people to shepherd those things. So don't give up hope. Don't give up hope. This will give us the correct answers to accuracy now. Now we've got the correct answer. That looks good. That looks good. All right. So we did the test. Let's do the train. Let's do the train and the test. All in one, you guys. There we go. Train, test. Okay. Let's see if we did a good job. Let's see if we did a good job. Actually, I'm kind of curious, you guys. Do you think we'll get above 20% accuracy? Let's say 30%. All right. All right. Will our model get more than 30% correct? Yes or no? Let's see what you guys think. I'm kind of curious. We're going to find out right now. We're going to find out. We're going to run it, and we're going to see what the actual accuracy is. I'm kind of curious. I think we're going to do pretty good. I think we're going to do pretty good. Here we go. It's going to train, and it's going to learn, and it's going to give us the answer. The loss is going down a lot. So you see, we're learning. The loss is going down a lot. We're looking good. Every time, looking better and better, right? Dropping down, dropping. It's already below 1. It's already below 1, which is amazing. Here we go, guys. Are we going to do it? Just checking real quick. Are we going to do it? Whoa, look at that. 88%. Oh, we look at that. Whoa, all right. I call that a big success. That was really good for non-optimal. I mean, somewhat optimal. We did mess around with it a bit, right? We messed around with it a bit, right? Just a smidgen. We could increase the epochs. We could increase the units. We could do a couple of things there. 88%, not bad for a non-convolutional neural network. It's just a standard MLP or DNN. There you go. Or an ANN, right? Well, and DNN is a DNN, deep learning neural network. You think some companies, let's see, yes. Let me learn another, yeah, okay. Rereading your chest, you already read. Rereading chest, okay. We did it, you guys. Success. I call that success. Okay. So, is there anything left? Is there anything left that we need to do that we missed on? Let's go to the tutorial. We got our accuracy. Yep, times 100. Yep, there we go. Let's see. Now, there's something else. What is this right here? What? Oh, this is everything all in one. We initialize the loss function to optimizer and it passes through a train loop and then a test loop. Feel free to increase the number of epochs to track the model's improving performance. So it says 10 epochs is what it thinks is a good idea. Let's do 10. Let's do 10. We'll bump it up. We'll bump it up real quick. Let's do 15. And we'll let it run. We'll just let it burn. Let it burn, you guys. All right, while it's burning, let's take a look here. Yeah, we did that part. We did that. Oh, we're done. We did it, you guys. We went through the most difficult part of the Pytorch optimizations. The optimization. This was, actually, it's the most fun part. It's the part where the AI is learning, right? The optimizing the model parameters. We did it. We made it work. How do we get the really pretty percentage tracker? How do we get the pretty percentage? Because I'm only doing like a raw number. How do we get the percentage tracking? How do we do that? Where's that at? How do you do that? Not very comfortable with how people are using AI to vibe code. I know, right? They're just spitting out code. I think AI is amazing to suggest, not to replace. It's important to somewhat understand what the code means. It does. And that's why, as software engineers, we're in a good spot. Because the future is going to need us more than ever. Because everyone is going to be writing code. Everyone. Right? Even at the grocery store, you'll be writing some code. You'll be writing some code there. And we need some help from experts to know how things need. Indeed, exactly. Exactly. How do we get the pretty output? Oh, we don't need that. Okay, never mind. I know what that is. That's the download. That's fine. We're good. We don't need that. We don't need that. Although I would like it. I would like it for this. Okay. It's still at 88% even with 15 epochs. Interesting. 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 All right, let's mess around with it a little bit more before we move on to the next segment. 88%, huh? Only 88? I feel like we can get better. Let us increase this number. Higher learning rate. And we will go to 784. So that way everything passes through. Hey, Sky, good to see you. Welcome on in. Happy Friday. Literally very bad at vibe coding. Oh, it messes your head every time you try it. Oh, Bra Machina. Bra Machina, you know what? It is another skill. It is. Even if you're a seasoned, multi-decade professional software engineer, writing code with the AIs is a little bit challenging. It's some trickiness there. It's some trickiness because it's a new skill. It's China, actually. Wait, what do you mean? That's not where I didn't think you were going there. ChatGPT 5. Yep, gotta use the ChatGPT 5s. Yeah, Norma, you got it, Norma. OpenAI, ChatGPT 5, Claude, Opus, Gemini. My name? Oh wait. What do you mean your name? Rob. Oh, your name, it's a China actually. Oh, your name is China. Is it really? Your name's China? Oh, that's not what I thought. Oh, I thought you were talking about the country. I also don't get how vibe coding might be useful in the way of earning money. Like, we're doing it right now. I can tell you that it works today. It's working very well for us at my company. Certain that AI will not be able to put ads. Oh, yeah, it might. Or the app purchase. Oh, you're editing the purchase because that would require personal things. It sure would. Circuit 12. We got the Circuit 12, Norma. What else can you say in there? What else? How about complementary metal oxide semiconductor? Try that one on. No Bluetooth. Yeah, got some Bluetooth in there. Bra Machina. Okay. China. Sorry, China. It might take me, It might take me a while to remember. It takes me like a couple of streams to remember. You like it for brainstorming? It's good for brainstorming. It is. I use it for fully building everything. This chart is utterly fascinating. Wait, Gok, which chart? Which chart are you looking at? Let's see here. Oh. Who's that? Ray? Ray, thank you for subscribing. Appreciate it. Ray Rashma. Rasim. Ray Rasim. Good to have you here. Thank you for subscribing and joining the right channel for software engineering. We're becoming Pytorch experts. That's the plan. We just finished the basic tutorial. Today, we will finish it, and we're going to move on next week. On Monday, we'll move on to the next level of tutorials. Houston, do we have a problem? Norma, bye. All right, sounds good. Coding, Houston coding. All right, you guys. Let me double check. Let's got that right there. I can increase the batch size because I've got more memory on my machine. So let's do batch size. Let's go 128. Let's boast it up. Let's go double speed. You guys. So you see how this is pretty slow? We're only like at 30% here. Let's boost it up to double. Hey, there we go. Oh, now we're bumping single digits. Oh, now we're boosting. I like that speed right there. Are you using Jax or Flax? We are using Pytorch. Thank you for the hearts, you guys. Thank you for the hearts. We are using Pytorch, and we're going to become Pytorch experts. Eventually, we'll move on to Jax. We will. I want to try to learn that framework as well. We'll do Jax. Thank you, Pravin. Thank you for mentioning it. Thank you for mentioning it. We will make it happen, you guys. Okay, here we go. Do we get a better accuracy, or are we stuck at 88? Oh, it dropped down 1%. That even made it worse. Really? That's crazy. Is there anything in here that will make it better? The only thing I can think of is turning this to a CNN. Convolutional neural network. A CNN. All right, I think we're good enough. Okay, let's move on to the next segment where we're going to save and load our model. Do you know what are logic gates? Yes, I know about logic gates. Right? You got your and, you've got your or, well, right. And, or, XOR. Right, XOR. There you go. How's it going there? Content creating? E30, welcome on in. Thanks for saying hi. What does the percentage mean in this context? So we've got the amount of data that it's been trained on. That's like our training progress, essentially. So we're training it for 15 epochs. So we've got an entire data set. We're training it on the entire data set 15 times. And that's just the progress until it's done learning. That's what that means. The loss is how sort of precise it is when it is making predictions. It says how wrong the model is. It tells like how off it was. The accuracy is how many times it correctly guessed the exact answer. Absolutely agree. Yeah, also use AI for learning. Saying that replaces humans as exactly not replace. It won't replace humans in actual game, app, and web development. At this point, it's not replaced humans. It's just it's a tool that makes us able to write code faster. Is that more productive? I think it is, although it really depends on the one who's vibe coding. If you're vibe coding and you're creating ginormous documents and you're just creating just a torrent of text, is that good or bad? I don't know. Are you achieving your goals more quickly than you would ever be able to achieve them before? I think that's part of the answer. Okay, you guys, let's go to the next phase here. We're going to be loading and saving our models, and that will be it for today. 20 minutes. Models.models. Torch Vision.models. Do we need that? Model equals some sort of magnet 1KB1. Hold on, let's learn about this. Pytorch models store and learned parameters in internal state dictionaries called the state dictionary. So you can just say .state dictionary. These can be preserved via the torch.save method. With the state dictionary right there, look at that. Okay, got it. Okay. So that's really easy. That's so easy. Okay, let's do that. Let's write a save function, you guys. Def save. We'll do torch.save model.state dictionary, like that, and then we save the save file. We'll call this our fashion dot what file? PTH. Okay, just like that. Is that the way to do it right there? We don't need to put that in a function. Let's put it right here. And then we'll test to load it. We'll do it load and we'll set the model up ahead of time before we do the training. So we'll train once. This is what we'll do. This is the plan. We're going to check to load the model. So here's our to-do items. Don't know what's going on, but I'm here now. Oh, Slimeball, thank you for joining in. Slimeball, good to see you. Happy Friday. We're doing Pytorch. We're going through every single Pytorch tutorial. We're going to become Pytorch experts. Let's do it. We're becoming Pytorch experts, you guys. Live here on stream. We've got through the introduction tutorial. We understand how everything's working. Now we're on the very end. This is the last page. It's the last page. There's nothing left. We did learn the basics, the quick start, tensors, datasets, transforms, data model, autograd, optimization, which is the actual training of the model. It's called optimization. And now we're going to save and load the model. We're going to save and load it, you guys. You're scared about regarding vibe coding. You feel unmotivated because in your mind, you're thinking, what am I learning? Right? You're not. Is it even worth learning? Since there's AI which can do it way better. I've been doing this for multiple decades as a professional software engineer, and I've built many large systems on mega big data systems. And the AI can still write code better than me most of the time. Isn't that crazy? So would you want to spend multiple decades trying to get not even as good as the AI? I think that's out the window now. All those years that I've spent learning, I still think are valuable because I can apply that when I'm working with the AI. So I feel like there's value there. I don't run into some of the problems that I've seen some of my other team members, they run into problems while vibe coding because they don't maybe have some of that foundational knowledge. I do not hit those problems at all while vibe coding. I don't. What's your favorite language? Rust. I like Rust. And then from there, it goes to Python, and then to JavaScript, then maybe Perl, Golang, and the worst language is, you might not like this, Java. That's the worst language, Java. Why? Not for many reasons. One, it is the most expensive, slow thing that I've currently got running at my company in two specific fashions. Ridiculously high cost. It often runs out of memory, and coding with Java is not fun. It's not. Hey, Golden Knight, good to see you. Welcome on in. Thank you for saying hi. Java is just, from a business perspective, it's fine as long as you're not going to be doing anything big or important. That's how I say it. Perl, that's an esoteric choice. Well, you know, Amazon.com used to be the largest Perl shop in the world. A lot of their code, and probably still today, still has some Perl in it. Amazon.com. That's where I got most of my Perl from, was from Amazon. Because I'm in Seattle, and they're all over the place. Perl, yeah, I like Perl a lot. I really do. I still use a lot of regular expressions. I use for command line stuff. Some sed. I like my sed. I like my regex, and that's where Perl is. I like my Perl. It's faster than Java, and it uses less resources than Java. So, like, why would you choose Java? And the coding is more concise, although it's cryptic. It is. It's cryptic. So I understand that part. That's why I like Python, because it's not cryptic. Okay. Did we do this part correctly? Let's save the model. Model state dictionary, and then the file. Okay. Fashion.pth. After we train it. Okay. So, what we need to do is, to do load model if it exists. If it already exists. What CPU are you using? Well, Java is horrible, but some crazy dude decided to make a game engine, and it has... Oh, what's the game engine? Which one? Which game engine are you talking about? Which game engine? What CPU are you using? Epic Blocks. This is a Mac. It's a Mac CPU. It's a regular HTOP, right? So there you go. It looks pretty good for a consumer grade system. Pretty good for a consumer grade system. Pretty fast. Epic blocks. Your model will get 30% or more correct of what? Oh, yes. Oh, first Dr. Dredd. I'm talking about Minecraft. Oh, yes. That is why we have Bedrock. Because Java's slow. Right? Right, loons? They rewrote Minecraft in C++ because Java's slow. And that's why they have a new Bedrock version, which is not that new anymore. It's not that new. It's not. They're talking about Minecraft game engine. Yeah, yep. You know what? The 30% was our. So that's an old poll. I closed the poll. We're done now on the poll. Everyone said yes. You all knew it. You all got it right. Good job, you guys. Good job. That's impressive. Yeah, we did. We got really good. So the accuracy that we got was about 88%, 87%, which is well above 30%. I see, first Dr. Dead. Yeah, we did a good job, you guys. Good job, you guys. I'm happy about that. Okay, let's keep going. Happy to have you here. Happy Friday, you guys. It's the weekend. It's almost the weekend. Oh, I'm so excited. Although I have to do a bunch of chores and things like that. So I'm still happy. You can still be happy for that, right? Kotlin, since, yep, exactly. GAC, you know it. Kotlin or Scala or even Clojure for that matter. Might as well use that. If you're going to be using the JVM, don't use Java directly because the language is just so verbose. Kotlin is nice though. Yeah, it is. The JVM have a value proposition, right? Once run everywhere. That is a very good value prop. I agree. Java is pretty, yeah, exactly, GAC, exactly. You know it. You guys, we're on the same page. I like it. It's really nice to feel validated, right? When like you've had those opinions for years and like, Java's really good. What are you talking about, Java? Like, no. It's fine if you need it for a specific use case. It runs everywhere. And if you need it for a very lightweight something, it might not be the best for you. Or if you want to run it in a situation where it does not demand too much on the resource consumption side, then you're fine. Didn't want to have to be rude. Please don't talk about the terrible buggy knockoff of Minecraft. It's Bedrock. Hey, I run Bedrock. That's my favorite version of Minecraft. I play Bedrock all the time. The Java version has some really good, it does. It has really good mods. It does. Bedrock is caught up though. It caught up, I think. It took a few years. It did. And it runs a lot faster. You're ignorant about computer programming. To understand what's going on here, I hope you all have a fun day. Thank you. First Dread, appreciate it. I'm glad you stopped by. Sane, are you going to attend the NVIDIA GTC AI event? If it is a live stream, I might pop it open on my browser tab. I won't go in person. I won't go in person. I have considerations on that matter. Okay, let us load. Let's finish up this. Let's do this, you guys. We're going to wrap it up. We're going to do a load. How do we do load? Model.eval, load state dictionary, load model.load model. Okay, so we can just straight up do a model.load. Wait's only true. Okay, let's try that. How do we check if and how do we do a stat in Python? Does anyone in chat know how to do a stat in Python? What I mean is a stat which detects if a file exists. We want to check if the file exists. And the type of system is so nasty, Kotlin skips the null pointer trap. Oh, and it's beautiful syntax to boot. You're right. Kotlin is the answer to Java, you guys. Regarding Java, you got it. Aziz, good to see ya. What first thing you would ask a super all-knowing AI system? The answer to the universe. Are we in a simulation? What is the point? Where are we? Are we, in fact, the universe itself just observing itself? Is that what you are? You are the universe itself observing itself. That's what you are. Because we are made of the universe. That means that we are the universe and we are observing ourselves. Isn't that neat? I thought that was neat. I think that's neat. That makes you stay up at night and think about things. Okay, let's load our model. How do we do a stat in Python? Let's do this. Codex. All right. Is there a clear? There's how to stat file in Python, short, simple. It's been a while. I don't do this. No, is that what I want? Info path.stat. Okay. Is that shortest way to check if file exists? Is there a clean or short way? Path. Okay. That exists. Okay, let's do that. So let's import pathlib. Okay, we'll do that. We'll go from pathlib import path. Is that right? Do we do it like that? It is from pathlib import path. Okay. Nice. That is the answer. That is the answer. Pathlib. All right. So let's go over here. We'll say path. What was that? os.path.exist. Oh, why don't we already have OS? I skipped right past it. This is better. This is better. I like that better. Okay. 1 second. Delete. Delete. Improved. Our life's better now. Our life's better. All right. So os.path.exists. Is it plural? Was exists. Yeah. Exists. Okay. So we'll call it model file equals like this. Model file. Okay, there we go. 9. Yeah, here we go. Very good. All right. Load model if exists. Let's see. Otherwise, train and save. That's what we're gonna do. That's the plan. We're finishing up with the tutorial, guys. We're gonna do it. We're almost there. We're so close. I would ask it to do center a div. It'll center a div. It'll be like it will center it. It probably will. Do you think it'll use floats? No. Do you think it'll use what is it called? Flexbox? Do you think it'll use what is it? What is the evolution of Flexbox? There's something new, something beyond Flexbox. We just used it a couple of weeks ago. No Flexbox needed. I think the CSS standard got updated to make centering stuff easier. Yeah, what is it called? Do you use local LLM? I use remote LLM. I'm currently using GPT-5.4, as you can see right here on the bottom of the screen. This is GPT-5.4, right there. I don't know if you can see that on your screen. It should be right here. Right here, you guys. GPT-5.4. I also use Claude, and I use Gemini. I use all of them. Would you be a huge waste of resources? It would? Local? Oh, for now it would be, yeah, because I don't have enough GPU memory to waste. I really don't. Okay, so if, then we'll load the model dot, what was it called? How do we do this? Load state. Okay, load state dictionary, and we will say the model file, like that, right? Is that it? Oh, we have to do torch.load. Okay, wait till me. Okay. Let's see. Torch.load model file. WEIGHT waits only equals true. Okay. Let's see if we can get it to work, guys. I think we can. All right, let's reduce our epochs first to something short, so that way we can train it once and save it. No clue what it's called. I only heard it on passing. I'm allergic to front end. Haha, I'm a student of compilers. Hey, very nice. We're doing back in today. OCaml for the win. OCaml. Hold on. That was not on my list of languages. OCaml example. Let's see. Let's look at some OCaml example syntax. I like how Google knows what I mean when I type it in. All right, that's pretty clean. No big deal there. What is this? Is this a comment? No, that does not mean a comment. What's this? What's that mean? What does -:int equals? What does that mean? Gak, what is this right here? I have no idea what that is. I'm not familiar with this. -:int equals, does it assign some value to the negative symbol? What is that? What is going on here? OCaml? This is a very functional language, it appears to be. Very functional. Not a little bit functional, very functional. That's the REPL telling you what the, oh, got it. The REPL's outputting. So you're saying let y equal 50 in, okay, so where's, whoa, let y equals 50 in y times y. 50 in y times y. What's the double semicolon about? Hold on a second. Why are we doing double semicolons? Just because one is not enough? You need two? Why the double semicolon? What's weird? All right, that's enough OCaml for now. I don't have much time left. We've got a little bit of time left. I would like to, we're very close. We should finish it. We're very close, you guys. We're right there. We're right at the very end, you guys. We're right at the very end. Okay. So if, else, we're gonna train. Let's just bring that over there. And we'll save the model like that. Okay. Either way, we'll run the test. Either way, we'll run the test. Test it. All right. Load model if it exists. There we go. I think we did it. I think we did it, you guys. Did we finish it? Bring back some C# trauma. Oh yeah, the good old C#. Forgot about Grok. Oh, never mind. It's trash. Oh, is it? I don't really use. There's a couple with the semicolons. C#. Got the semicolons, you guys. Yeah, I don't get the weird double semicolons. You can use new lines and it works fine. Okay, got it. All right, so new lines and semicolons. They're just ways to, just in case. Also in Python, you can do that too, right? Python, 1 semicolon, 1 semicolon, semicolon, semicolon. Oh, it doesn't like that. It only likes it if it's 1 semicolon. 2? Is there actually a meaning in semicolon in Python? There's actually a representation of it. Invalid syntax. Apparently it does something. What is the semicolon in Python? Let's find out. Let's ask the AI. What is semicolon in Python? What does that do? What does that operator do? I'm pretty sure the pep bans it, LOL. It does? Oh, it lets you do multi-line. Pep, Bo, you're right. The pep, yeah, it might. You might be right. The pep might ban it. Separates multiple statements on one line. I've never done that before. I didn't know you could do that. Is that Copilot? This is Codex. And we're just asking it questions. It's in a terminal window. We're not relying on it heavily. We're just using it for very basic stuff. For the most part of the channel, we're keeping things pure. We're keeping it pure. All the code we write will be code coming from this brain here. We will, for the most part, Senko. We will, Senko. Oh, that is cool. Yeah, that's cool. It's great. The Codex TUI, the terminal user interface for Codex, is very nice. Gemini, also very nice. Claude, on the other hand, is slow and it takes up a bunch of memory. Watch this, htop. htop / Claude. Look at that. Right here. Right here, you guys. That's Claude. It's currently using 5 gigabytes of RAM. Claude code. The terminal interface, Claude code, is using 5 gigabytes of RAM. It's ridiculous. Wow. Yeah, it's the right. You got it right. Wow is the correct statement. What about C+++++++? Fun fact, using semicolons in Python is the best way to hide malicious code and open source. It sure is, because I've been doing it for so long. I've not used semicolons and I would never expect it to happen. It's really good way to hide. Yep, you got it. To do nothing but network requests, basically. Exactly, you guys. It's insane. How would this affect quantum computer? Oh, it's different. A quantum computer can calculate, at least the existing quantum algorithms can only calculate optimization functions, as far as I can tell. It can optimize on very hard maze and travel problems. Because it's basically, it shines light through a mesh. I call it like a mesh shine. So you shine a light, like a torch. So you've got a torch, sort of like this, right? So you've got you've got your torch, right? You've got a light, and then you've got a grid that you throw in front of it, right? And those waves, you put another grid in front of it, and another grid, and you rotate the grids, And eventually there's something that comes out on the other side. And you grab the brightest value on the other side. The brightest value. Noel, thank you for subscribing. Appreciate it. Good to have you here. Here's some more grid lights for you. You got the grid lights there. That's what a quantum computer looks like. Rainbow colors come out. Exactly. Rainbow colors come out. You get an answer, and you either look for the global minima or the global maxima, whatever the value is you're looking for. And it's just like shining a light bulb through it. 3 blue, 1 brown video about QC is great quantum computing. It's a good one, you guys. It's a good one. I'd never use semicolons because if you did, it wouldn't be able to properly flex the amount of lines of code you coded. That's right. You could do it all in one line. You could. Wait, I have a question. What's that? What's that? Okay. Let's close that out. Let's go back over here. We're right at the end, you guys. This is it. We're at the end. Did we do it? Did we win? Okay. Looking at the code right now, you guys. Let's do a poll. Will this code work? All right. Will this code work? Yes or no? Okay. What's your question? You've got one chance, a yes or no. I think the answer is yes. I'm feeling pretty confident. Torch.save, model state dictionary, model file. 4 epochs in range. We know this line works. We've been using it forever. This is the line that I don't know about. If the file exists, which it won't, and then it's going to train and save, and it will test. So technically, it should work. I believe too. I like how you guys are 100% confident. 100% yes. You know how many times we've run our code and it came out with errors? It's like 90% of the time that we run our code, it came out with errors. Just to let you know, if you were betting from an odds perspective, you think Claude is just an Electron app, so it's full instance of Chromium running. No. No. Never mind. All right, yeah. It's running React. So it is. It's yeah. React in Claude TUI, right? In the Claude TUI, CLAUDE TUI. So yeah, slow and lots of memory. That's one of the things about Claude TUI. They really need to rewrite it. It would be so nice if they just rewrote the interface. I bet you got it to work. Yeah, nice. I bet you're right. Stopping functions if loss remains the same. Oh, stop early. That would be a good idea. That's a good idea. You know it. All right, we're gonna add some extras to this. Here we go. Let's add a little bit of extra. Let's drop this down to 2. Okay. We'll bring this over to 512. Okay. Because we got decent answers like that. We got decent answers. Okay. Perfect. I want to leave that up there. All right. Do we have model.device? Do we use device anywhere else? We have to do this. We have to do it like that. Okay. Got it. Understood. All right. You betting. All right. We're going to try out why are there no neon colors like neon green, neon brown for every color? I've never heard of neon brown. Neon green, though, definitely exists, right? Use Claude as your main AI, and I think it's great, but expensive. I do too. I use it as my AI. It's great. It's great. Okay, you guys, are you ready? We're going to make it happen. We're going to find out. We're going to find out if it works or not. Here we go. Wait. Hold on. We need a different song. We need something better. 1 second. Let's go. Let's reload this real quick. Okay. Let's go with this song over here. Okay. There we go. All right. Let's see if we get it working. Okay, here we go. Boom. Brown is anti-neon. You know it. Yeah, it's the anti-neon. Very much anti-neon. Here we go, you guys. Did we finish all the Pytorch introduction tutorials? Did we finish every single one? I think the answer is yes. If this passes, we did it. We have to run it twice. So we're going to find out. We're going to find out. We'll run it twice. Neon is an optical property of where some wavelengths of light are shifted to contribute to other colors. Brown is the opposite. Oh, it's an inverse of that. All right, here we go. Okay, so far so good. If we run it the second time and it does not train. And it loads and it works and we get 80% accuracy. We're good to go. This song's like top 10 things you didn't learn from school. Wait. Oh, it is? It is? It's a good one. It's one of my favorites. It's one of my favorites. Boom. 86. Oh no! No! Hold on, we did it wrong. All right, what's wrong? Oh, we got a typo. We did a typo, you guys. Load state. Whoops! Oh no, we do typos here. All right. Whoops. All right. How about now? Nope, still not. Okay. Model.loadState got an unexpected keyword argument waits only. Oh, did I misspell that as well? WEIGHT only. Is this? Hold on. Wait. All right. Don't give up yet. Don't give up yet. Waits only equals true. Oh, on load torch. Okay, sorry. There. Okay, tragic. I know. Well, it sounds like it. Oh, hey guys. Oh wait, man. I can ask a question. Yes, Adam, Mister. Let's do it. Ask the question. Here we go. And now it's actually gonna work. Hey, there we go. We did it. We just completed all the Pytorch tutorial basic introductions. All right, we did it. We made it work, you guys. Do you use Vim? Yep, we're using Vim right here, you guys. Yes, we did it. Vim. Yep, you got it. Right there, Vim. This is the one I use. Version 9.1.1752. GG's. We did it, Guac. We did it. Success, you guys. 86%, pretty good for a non-convolutional neural network, simple deep learning model. We did it, you guys. Thank you. All right, BRB, and then we'll wrap up. Can you run the drawing thing? Yes, at the celebration. This one or this one? There's two of them. They're both still open. Which one, Redless Saber? The line, so they've got the line one or the other one. I like this one because it's getting pretty. The second one, this one? Okay. BRB. 1 second, BRB. Okay. We did it. We succeeded. We succeeded, you guys. We did it. We completed the tutorial. Okay, so let's look through this here. Save, load. Torch.load. Oh, wait. Can we just do this? It looks easier to do that. Why do we do it the other way? Let's see here. Okay. Well, I've been trying with Vim. It looks cool. It's actually cool. You would like to code with it without needing to quit and actually try the code on a compiler. You don't want to use... Oh, the good news is you can use tmux. So you can just switch between windows, or you can split windows and do your stuff here like on a separate window. So you can use window managers. You can do, or like terminal splitting managers and things like that. You love VS Code? Hey, that's the thing. You just wish it wasn't an Electron slop. Yeah, it is. It just takes a little more memory. Vim is nice. It's lightweight. It's fast. It's efficient. Runs in terminal. You can easily bop in and out. So quick, fast, and quick and easy. No problems. Everything runs instantaneous. That's why I like to use Vim, because everything's right there. All in the terminal window. Even the AI is right there. Yeah, tmux is really good. It's great. I love it. It's fantastic. All right, you guys. I want to try using not this. I want to try it different. So I'm going to say model equals torch.load. What's it called? Torch.load. And then the model file. Yeah, just like this. Can we do this way? Let's try it. Like that. Like that. Right there. Let's try this. All right, wait. I want the green grass one. Where's that at? Where's my green grass? Where is my green grass at? Danger. Blue. Culture. Patrick. Where's that? Where is it? Requiem. Green. Oh, here we go. Is this it? No, that's not it. It is green orbs though. I want to wrap up this last song for Friday. There's one song I really want. This one? No, not that one. Dancing. Eerie, this is it. No, that's definitely not it. It's not there. I don't know where it is. My favorite one. Oh, man. Oh, well. Okay. We'll just wrap up with this, you guys. Okay. Reasonable. Haha, that was the entire library of the Incompetech. It was the entire library. Anyone likes VS Code? It's kind of a task down when using VS Code. It doesn't give you the vibe. Hey, Adam, the idea is use your favorite text editor that makes you happy. What text editor do you use? The one that makes you happy. That's what. Know the song before, man? It's the nostalgic one. Oh, I missed it. I don't know which one you're talking about. It reminds me of the time when you were young and watching stupid stuff. Yeah. I know what you're talking about. All right, you guys, we did it. Let me double check if this is what we wanted. Is it going to work? Model.eval. Okay. So this doesn't work, apparently. Apparently that doesn't work. We have to do this. So I want to do that. Let's double check. Use VS Code because it's the only one I've tried. Oh, there you go. No worries. I want to do this. I want to do this right here. Let's try this. Call it the model file right here. Yes, please go. Yeah, please. Yes. V. There we go. Okay, let's try that. It still doesn't like it. Okay. Oh, we're good. We'll just have to do it the other way. It's fine. We'll just have to do it the other way. I like this syntax better. Why isn't it? Why not like that? As described, saving and loading the torch model, saving the state dict is considered the best of practice. However, below, if you use waits only false because it involves loading the model, which it's a legacy use case. Okay. Got it. Okay. So we will just do this. Like that. Just like that, right? Okay. Make sure it works, and we're good to go. Pytorch playing with AI and stuff. Cool, yeah, Adam, exactly. Hey, I'm late because what exactly are we coding? So we just finished, you guys. We did it. We just did it. We finished. We got through learn the basics, quick start, tensor, data loaders, transforms, build your model, auto grad, optimization, which is the learning of the model, and saving and loading the model. We did it. We succeeded. Introduction to Pytorch YouTube series. So we don't want to probably watch some YouTubes here. Running the code tutorial. So yeah, okay, got it, yeah. So we don't need to go through this, although maybe we will. We might go through this because it's starting to bring into some convolutional stuff here. Sick, yeah, no, it's great. And that's new subs. Many men deserve it. You deserve it. Thank you, Adam. I appreciate it. So the plan for next week, we will continue going down the Pytorch tutorials path. So this is a different tutorial. Autograd, building models, TensorBoard. Ooh, TensorBoard support. I don't know what that is. Training models, model understanding. We'll go through this next one. So this is where we'll start next week. This is the introry tutorial. It's a different one. We'll go through it. It looks like it's got some extra stuff that we didn't see before. That's the plan for next week, you guys. We did it. We succeeded. We got it to work. I'm so happy about that. Right there. Boom. Easy. Okay, accuracy. We can make it better, though. We'll want to convert this into a convolutional neural network and make it work. TensorBoard is a UI for training. Gok, thank you for the art, you guys. We did it. We succeeded. I'm actually really happy. That took a lot of consideration. It's a web UI. Got it. So it won't work in my terminal. That's okay. I want to become a Pytorch expert. I need to know everything there is to know about Pytorch. We know enough about AI. I just don't know enough about the framework. Hell yeah, let's do it. So that's the plan for next week, you guys. On Monday, we will be back. We will go through the rest of the next segment of the Pytorch tutorials. Oh, you're making your own AI. Yeah, you know it. That's the plan. So we've made many AIs on this channel. We wrote AI from scratch, AI in frameworks, AI with Rust and JavaScript and Python. We will be doing more AI. The plan is for Monday, we will be bringing in the next Pytorch tutorial. That's the plan. Interesting. So I need to be spongy like you. All right, yep. I think sounds the spongy. Got to keep it spongy, you guys. Keep it spongy. I'm gonna wait here for it just to tell me when. All right, we're good to go. So we're wrapping up on Monday. Yep, we'll be back on Monday. We're headed out, you guys. It was so good to see ya. See ya. We'll be back on Monday for more Pytorch tutorials. We're gonna become experts. Can you say bye to YouTube for me? All right, bye YouTube. Bye YouTube. Good to see ya. We'll be back on Monday. Hi everyone. See you on Monday. Good night. Thank you so much for joining. Bye, everybody. Good to see you, man. Good to see you, too. More Pytorch on Monday. We're going to make it happen. It's going to be great. I'm excited. We made a lot of progress. We found a lot of problems. We found some bugs in the tutorials because they're old tutorials. Thank you for the reactions, you guys. I'm here. Plashless, good to see you. We're wrapping up. I'm pressing the end stream button now. It was good to see you. We'll be back on Monday. Monday with more Pytorch. All right, you guys. Thank you so much. See you Monday. Bye, everybody.